Welcome back. We're in lesson 20 and today we're going to talk about volume. In lesson 15 we defined a geometric solid as a geometric figure that has 3 dimensions. Now in lesson 15 we talked about surface area, so we took those 3 dimensions, that box or that shape, whatever it was, and we talked about just the outside surface. Now we're going to talk about the inside capacity of whatever the shape is, and that the capacity is something that we'll refer to as a cubic unit. And we call it cubic because it has 3 dimensions. It has a height, it has a width, and it has a depth. And those are the 3 dimensions of volume. It's also the 3 dimensions of something that is spatial. It's more than just something flat. Like a piece of paper is 2-dimensional. It only has a length and a width. This has also depth added to it. As you can see here, a box is a 3-dimensional shape. A cup, a pot, a plant is a 3-dimensional shape. Anything that has height, width, and depth, you are a 3-dimensional shape. In this lesson, though, we're going to talk specifically about the cubic volume. And a cube has 6 identical square faces. Remember, we talked about in lesson 15, finding the surface area of a cube would be easy because all we'd have to do is find the surface area of one and multiply it by 6 because it has 6 identical square faces. Now, volume is always measured in cubic units, and that means instead of having a unit of measure that looks like this, that should be a 2, we're going to have a unit of measure that looks like this. So whatever the unit is, we'll have a 3 on it because that represents the 3 dimensions of a volumed shape. Okay. Let me see. Let me erase this for you. All right, moving on. So in this shape here, if we look, we will see there is, here's our 2 dimensions right here. So in this shape, we have a height and we have a width. But now we also have added the depth. And if this was 1 unit of measure wide, 1 unit of measure high, and 1 unit of measure deep, then we would say we have 1 cubic unit, because 1 times 1 times 1 is volume for a rectangular geometric solid. And that is the standard formula for volume, and that's going to be the length times the width times the depth. You're going to want to write this on your back cover of your notebook for the sake of keeping that dimension straight. Okay? All right. So if you remember, area was length times width, right? So by definition, you could say that volume equals area times depth. Okay? All right. This is the one, this is what it is. This is referring back to area. This is what we're going to use for all of our odd shapes. You could definitely do this for a rectangle, but when you get a weird shape that doesn't have a specific way to measure it and you're just given the area of the base, you take that area and you multiply it times the depth or the height or whatever that 3rd dimension is that they're giving you, and that's going to be the volume. For instance, in this triangle, by the way, is going to be example 20.1. This triangle has a height of 8 and a base of 4, and it is in centimeters. These are all centimeters, and it is 6 centimeters deep. Let me put the cm here. All right, so in order to get the area of a triangle, we know that the area of a triangle equals the base times the height divided by 2, right? All right, so we're going to take the base times the height divided by 2, and then we're going to multiply that. Actually, let me undo that for you. So the area of a triangle, the volume of a triangle, is, that's not a great triangle, is it? The volume of a triangle is going to be the area of the triangle, which is base times height divided by 2 times the depth, right? That's how we're going to find the volume of this triangle. So let's first find the area. So the area is 8 times 4. That's the area of the triangle. You have 8 is there, 4 is your base, 8 is your height. So it's going to be 4 times 8 divided by 2, which is going to give us 16, and that's going to be centimeters squared, because we had a centimeter here and a centimeter here, so it's 1 and 1 is 2. Okay, so now we're going to drop in 16 centimeters squared times 6 centimeters. That's for our volume. Okay, we got this, we put it here, and 16 times 6 is going to be 96, and it's going to be centimeters cubed. I want you to look at something. We have centimeters with a square here. If we pretend this is another one right there, 1, 2, 3, we can just add them together just like regular exponents. So we have 96 centimeters cubed is going to be the volume for this triangle. So write this down in the back of your notebook. Volume of a triangle is the area times the depth, and this is the area of a triangle. You should already have this one on the back cover of your notebook. Okay. Now, if you have all of that, we're going to go to the next page. If not, pause, write it all down. I'm going to the next page now. So in this example, this is example 20.2. Write that up here for you. We are given a weird looking little shape here, and we have to find the area times the depth, right? And we have a depth or a height, it doesn't matter what you want to call it. It's that third dimension, and that dimension is 8. But we have a weird shape. So if you remember when we were finding area before, we would find two shapes, or we'd break it down into shapes that we could understand. So again, let's do that now. So let's remember that our volume equals area times the third dimension, whatever that is. Right? And in this instance, it's going to be height. It could be depth, it could be height. It just depends on which way you turn your shape. If your shape is sitting down with this on the bottom, like this, then this is going to be depth. If it's laying back on its side, then it's going to be height. It doesn't matter what we call this. It's just that third dimension. That's what I want you to see. You got to find that third dimension. So let's break this up. into shapes that we can actually recognize. All right, so here's a shape. We'll call this A1, and we'll call this shape A2. So let's get the area of A1. A1 is pretty straightforward. It's just a rectangle, and it's 4 by 6. So the area here is going to be 4 by 6, and that's 24. Right, and this is in meters. All right, everything is in meters. So I'm going to write that here for us, meters. All right, so let's find the area of area 2. So it is a triangle, so it's going to be base times height divided by 2. And that in this case, we have a height of 6. We see that's a parallel line. So we have a height of 6, but all the way from here to here is 10. So we need to know the difference from here to here. Okay, so from here to here, it says it's 4. So 10 minus 4, this part has to be 6. If this is 4, if the whole thing is 10, this is 4 and this is 6. So we have 6 by 6 because we can transfer this over. So 6 by 6 divided by 2. So 6 times 6 divided by 2. That's going to be 36 divided by 2. That's going to be 18. And this is meters squared, meters squared. Now we can add those two together. So the total area is going to be 24 plus 18, and that's going to be 42 meters squared. Okay, we know that the volume is going to be area times that third dimension, and that third dimension here is 8 meters, so times 8 meters, that's going to equal 336 meters, and that's cubed because we have 1, 2, and another one, 3 dimensions. Okay, so 336 meters cubed for this shape. All right, now moving on, let's do 20.3. As you can see, we're just taking these shapes apart and finding the area and then multiplying it times the height. Now, in this example, we have a radius of 3, and we have a height of 6 and a width of 5. And here, our depth is going to be 10. And this is all kilometers. Okay, so the easiest thing to do is going to be to break this into the shapes it's already given us broken into, right? So we have area 1 here, and we have area 2 here. Remember, the area of a circle, the area of a half circle, well, let's go ahead and do A1 first. So A1 is just straightforward. It's 6 times 5. So 6 times 5, and that's going to be 30 kilometers squared. And then area 2, remember the area of a circle is pi r squared, but it's a half circle, so we divide it by 2, right? So the radius is 3, so 3 times 3 is 9. 9 times 3.14, so it's going to be 9 times 3.14 divided by 2. If you do all the calculations, that's going to end up being 14.9 .13 kilometers square. Okay, so we have the area of area 1 and the area of area 2. We're going to add those together, and we're going to get 30 plus 14.13. So it's going to be 44.13 kilometers square. Right, now to get the volume, all we do is we take the area times, in this situation, because the way it's sitting, it's going to be depth. Okay, that's that third dimension. We're calling it depth. So it's going to be 44.13 km square times 10 km, and that's going to equal 441.3 kilometers, and that's cubed. All right. Pause if you need to, write all these down. All of these are what you need as your example so that you can figure out how to solve these problems later in your homework. So write these down well so you can see where everything goes and how everything is solved. I'm going to page 3. Pause if you need more time. So now we have a right circular cylinder, and it has a radius of, draw the radius here. It has a radius of 6 inches. Everything is in inches. And it has a height of 11 inches. All right, and this is 20.4, example number 20.4. My pen is messing up. I might need to change the tip again. It seems to go out pretty quickly. So first of all, let's remember the area of a circle. Okay, area of a circle equals 2 pi. No, that's the circumference, isn't it? I'm messing up. Whew, it's late and I'm trying to do too much work, so I'm getting confused. But that's why you write it down so you don't make those mistakes. You look back at your piece of paper and go, oh yeah, this is the formula. So the area of a circle is pi r squared. And because we have the whole circle here, we don't have to divide it by 2. All we have to do is drop in our numbers. So the radius is 6. 6 squared is 36. So 36 pi, okay, that's going to be, technically, that's going to be 36 times 3.14. Right? And let's see, that's going to be inches squared. And we are going to multiply that by 11 inches. Okay? So we have 36, where's my calculator? I'm going to bring it up for you guys so you could see it. Sometimes you just have to use a calculator. You can't do everything in your head. There's nothing wrong with using a calculator. That's why God made them, for the big stuff. 36 times 3.14 equals 113.04. Right, so 113.04 inches squared. Now we have to do it times the height. So times 11 inches in height. And that is going to give us a total of, I'm going to bring my calculator back up because that's a big number. So times 11, 1,243.44. So 1,243 43.44 inches, and now we have that extra unit of measure, so that's 3 units of measure, so it's cubed to that 1243.44 inches cubed. And that's the volume of this cylinder. Who thought that you only needed 3 lines to solve this? That's actually pretty easy, pretty straightforward. All right, there's one more that I want to show you. So if I'm going too fast, pause and write it down. And the volume of a circle is, again, simply the area of the base times the height. That's all it is. All right, let's look at our last one. All right, we have a weird shape here. And thank goodness they are not asking us to calculate this weird shape. They are giving us the dimensions of the area. We don't have to figure that out. And they're telling us that the height of this area, or the depth, however you're looking at it, is 15 feet. All right, so this is easy. All we have to do is say 52 feet squared times the height, which is 15 feet, right? 52 times 15 is 780 feet cubed. That's our answer. Oh my goodness. So you just take the area of the base, that's this part right here. We took the area of the base and we multiplied it times the dimension of the height. And that's our answer. So when you get those weird shapes that they go ahead and tell you what the area is, oh, just whip out that calculator and multiply this times this, write down the answer, you're done. Don't forget to put the 3 on your unit of measure. Don't forget to put the unit of measure, that's very important. And easy peasy. And that's all I have for lesson 20 on volume. And I'll see you in lesson 21.